Lesson 4.7 is on the real number system. And again, because of the Explain Everything you created for Chapter 2, hopefully some of this will be a review and it will go pretty quick for you. Remember, our essential question for Chapter 4 is, why is it useful to write numbers in different ways? And when we understand the real number system, we can see that there are several different ways to classify numbers and write numbers as fractions, decimals, and percents. So recall that rational numbers are numbers that can be written as fractions, and so we have a few examples there. And then we have irrational numbers that cannot be written as fractions. And when written as decimals, irrational numbers neither terminate nor repeat. And so it's kind of hard to even write those because the ... will just mean that they go on and on forever with no repeating blocks of numbers. And of course, they don't terminate. So there's some examples there. And then in words, an irrational number is a number that cannot be represented as a over b. And a and b are integers, and b is not equal to 0. So rational numbers can be written as a fraction, whereas irrational cannot be. And then this is one of many images that you can find online to represent the real number system. We have our natural numbers, whole numbers, integers, rationals, and irrationals. And remember that we also talked very briefly about imaginary numbers. So we have this group of real numbers, and then the imaginary numbers are its own category over here. And imaginary is a topic that you can maybe do some more research on if you're interested. Imaginary numbers stem from the square root of -1. And based upon our last section, we know that we can't take the square root of a negative number because no number times itself is equal to a negative number. We can do cube roots of negative numbers, but not square roots. So imaginary numbers are formed from the square root of -1. So you can do a little bit of research on that if you're interested some more. So computations with irrational numbers and rational numbers produce an irrational number. So if I multiply, let's say 3 times the square root of 5, then I'm going to get an answer of 3 root 5. And if I actually took the square root of 5 and multiplied by 3, I would get an irrational number. So computations with rational and irrationals give you an irrational number. Okay, so let's take a look at the top of page 175. Example 1 tells us to name all the sets of numbers to which each real number belongs, starting with natural, and then whole, integer, rational, or irrational. So you can look through those. Those should be pretty much review from what we looked at last chapter. Go ahead and hit pause and try to do examples 1A through 1D on the Got It section, and then press play when you're ready to check your answers. For 1A, it is rational, and you could say rational and real. For 1B, the square root of 100 is 10. So 10 is natural, 10 is whole, 10 is also an integer, 10 is also rational and real. 9/5 is a rational number. It's written as a ratio of two numbers, and that can also be written as 1.8. 1 and 4/5 are all different ways you can write that. 180% is another way you could write that. And then 1D, -6 is an integer and a rational number as well as real. For example 2, it's just asking you to replace the comparison circle with a less than, greater than, or equal to sign. And so 3 1/3 is 3.3 repeating. The square root of 15 is 3.8729. It's irrational. And 3.3 repeating is less than. So you would use the less than sign. In number 2, got it? Go ahead and write that on your paper. See if you can figure that out, and then press play when you're ready to see the answer. 7 2/5 is equal to 7.4. That's a rational number. And then 57, the square root of 57 is an irrational number. If I take 57 and then the square root, I get 7.54. And really, I only need that the tens place to make my comparison. 7.4 is less than 7.5. For example 3, it says to order from least to greatest. So we have lots of different forms of numbers, and each form has its own benefits. So sometimes we need to write numbers as fractions. Sometimes we need to write them as repeating decimals. So in order to put those numbers in order from least to greatest, it's nice to have a common format so you can do that. So go ahead and attempt to order 3. Got it 3, order those numbers in order from greatest to least. So pay attention to how you're going to order them. And then press play when you're ready to check your answer. In this case, 5 2/3 is the greatest at 5.6 repeating. And the next one is 5.6. That one terminates. And the square root of 30, and then 15/3, which is 5. So not too terribly difficult when we're ordering irrational numbers. The last thing we're going to look at is solving equations that involve square roots. And so in example 4, a squared is 38, and the operation that's going to undo our squaring is the square root. So we take the square root of a squared and the square root of 38, and we get a is equal to approximately 6.2 and negative 6.2. In the other example, the cube root would be the operation that undoes a cube, and so we're going to take the cube root of both sides to find the answer here. The cube root of 125 is 5. In the got it section, they actually threw in a coefficient. So the first thing we have to do before we take a square root of both sides is divide by 3. We want to isolate that d first. 3 divided by 3 is 1. So we're left with d squared. And then 363 divided by 3 is 121. 121 equals d squared. And to undo that squaring, we're going to take the square root of both sides. The square root of 121, it would be a positive and negative 11 equals d. Go ahead and try to do the other 3 on your own, and then press pause and press play when you're ready to see the answers. For 4b, 9 is the answer. 9 cubed is 729. In 4c, if you divide both sides by 4 first, you get 25 is equal to n squared, and the square root of 25 is 5 and negative 5. And then 512 is the cube of 8, so when you take the cube root of both sides, you get x equals 8. I don't believe example 5 is on your sheet, but let's just take a quick look at it. When you're given a formula that has variables and exponents, you do it just like any other algebraic expression where you substitute numbers in. So you can see right here the r and the a have been replaced with the numbers given, and then what you can do is you can multiply both sides by whatever the denominator is here, so you can isolate that x squared. So 50 times 4.5 is 225. And then you take the square root of both sides to get 15. Okay, so let's take a look at number 5. Again, you start with the formula here, and then you substitute the number in. So we have a depth of 632 meters. So I would write that as s squared over 632 equals 9.61. Okay, I can't just take the square root of both sides. I have to get rid of the 632 first. So I'd multiply both sides by 632. And that causes the 632 to cancel on the left. And I'm just going to take 632 times 9.61 on the right. So if I pull up my calculator, and it's fine if you use a calculator as long as you're putting in your work here and not just writing the answer down that you find. Okay, so I'm going to take 9.61 times 632, And remember, that's what s squared equals. So when I take the square root of that, I get 77.9, which is what's shown here. Okay, hopefully by the time you do your practice problems and take your quiz, you'll really understand how to do some of these operations and classify numbers. It should be a nice review from what we did last chapter.